Good morning, everyone. Thank you for joining our session. We are back again this week with a couple of good sessions lined up for today as well as tomorrow. Today, we will be having our session 8, which will be talking about AWS DevOps services, things like CloudFormation, CI/CD pipelines, and other configuration which help you to implement DevOps on AWS. And along with me, we will have Ishan Saha, who works as a platform engineer from Quantify, who will be sharing his experience and expertise around DevOps on AWS. So let me welcome Ishan with us. So let me give a quick introduction. So Ishan, as I mentioned, works as a platform engineer at Quantify. Along with that, he is also an AWS certified. He's also an AWS DevOps certified professional. So he understands the DevOps, the different services, and the best practices associated with it. And that's what exactly he worked in and out, right? So along with that, before I pass it on to Ishan for his introduction, let me quickly call out a couple of things. This is session number 8. We are almost have done a couple of sessions. So if you're still not part of our chat group where we share all the materials after the sessions, all the study groups, all the people interaction, please do join. The link is given in the description of the video. As well as if you have any queries and questions, please feel free to put it on the chat during the session. Ishan, and I'll address it as and when we get a chance. With that, let me pass it on to Ishan. Thank you, Ishan, for joining today's session. We are very much happy and delighted that you're part here and helping us to understand what exactly is DevOps and how things works on AWS when it comes to DevOps. Would you mind if you can go ahead and give you a quick introduction about
Uh,
yourself?
Hi Sanchit. Thank you so much for the warm welcome and hello everyone. So yeah, in this session, I will be explaining about the DevOps. So currently, as Sanchit mentioned, I'm working as a platform engineer in Quantify, where I work on various DevOps tools day in and day out. And I will also explain about the best practices that we have to follow when we work for the enterprise projects. So I think let's get started with it. So shall we go ahead, Sanchit?
Yes, please go ahead. Your screen is live, so you can go
Yeah.
ahead and yeah, best of luck.
Okay. Cool. Cool. Thanks. Yeah. So in this session, the agenda for this will be covering the various AWS tools, and we will first understand the importance of AWS, and then we will cover various tools like we will cover infrastructure as a code, which is CloudFormation, and then we will understand the importance of logging and monitoring, which is mostly underestimated in most of the projects. And then we will cover System Manager and Secrets Manager for storing the credentials, which is also very critical when we are having various DB services. And then we will, in the end, understand the various services tools available using which you can interact with the AWS. So let's get started. So first, we will understand the old way of doing things and why the DevOps and why the need of the DevOps came to the picture. So now consider a scenario where I'm having a developer working on some feature of a product, and so developer here writes the business logic, and once the business logic is done, then developer has to build the code, compiles it, and do various testing on it. For example, like a sanity checks and unit testing, all this testing, and once everything is done, then the developer hand over the artifacts to the operation team. Now, operation team comes into the picture where where they go to the environment and deploy the things. For example, if I'm having AWS, then they will go to AWS, log in there, and manually configure everything and deploy. So here we can see one thing that if a developer has to make some change to the product, then he has to follow the long path. And apart from writing a business logic, he has also to worry about the build and the testing part. Now consider a separate scenario. Now, the size of the team increases. Now we are having multiple developers working on multiple feature of a project at the same time, and all are building their code and giving their artifacts to the deployment team, which is the operation team. So here we can see that it will become a chaos, and it will very become difficult to manage and collaborate between the developer and the operation team, and things will become mess up. So sometimes it may happen that in order to do things faster, developer may skip some of the step. For example, they may not test the code properly and they directly deploy it to environment, which will result into which results a bad quality of the code, and it will eventually hamper the whole business. and we are not having any monitoring tool, and everything is being configured manually. So earlier, without DevOps, these kind of scenarios were happening. So we will now understand the other challenges that were around it. So first, we saw the whole process. For example, if I have to deploy a simple change, then we have to follow the long path, which is very time consuming, and it is also unproductive. And now consider we are having multiple environment. For example, most of the projects in the enterprise, we have more than one environment. For example, we have develop environment for development, then we have a separate environment for UAT testing, then we have a stage, and then we have production. So since we are doing everything manually here, so there may be scenario that something is working fine in one environment, if, for example, dev and UAT, but it is not working fine in production. So there may be chance of manual error because humans are involved with it, and we don't have any proper monitoring tool also set up. Because of this, we will not get proper feedbacks, and because of this, we won't be able to understand that how my application is behaving in production. And if some error comes, then also we will not be able to debug, and it will take a lot of amount of time to debug that also. So it will cause a production downtime. And if I have to upload or make some changes in production, there is not also a proper pipeline to hot fix the thing. So these were the all challenges. So now I'll also try to explain the things with the help of one meme, how life was without the DevOps. So here we can see that something is working fine in dev environment, but now the developer is saying it is working fine in dev. Now it is the problem of the operation team. So here we can clearly see the collaboration between the developer and the operation was not good without the DevOps. And the next image we can see, stand back. We are trying this thing in production because we are not having any pipeline. Ideally, what should happen? There should be a separate environment, and if I have to deploy something into production, then that change has to go through multiple validation. For example, it should first deploy to dev, then to UAT, then to stage, then in production. We should not directly implement this in production, but this kind of validation and process was not earlier. So now we will understand the DevOps, what is DevOps, and how it removes all the challenges that we discussed so far. If I have to explain DevOps in simple words, I can say, so DevOps is like a combination of various philosophies and tools, which allows the developer to focus on writing the business logic part of it and not worry about the testing and development. So the overall the build quality and the code quality will improve, and also the collaboration between the developer and the operation will also improve, because now we have separate roles and responsibilities identified. That the developer will be working on this part and operation guy will be working on this part. So now we will understand how this happens. Now consider the same scenario where developer is working on some features, and when the developer commits the changes to a code base, it will automatically trigger a pipeline. We will understand about that pipeline in the upcoming slide. But for now, we can understand that it will trigger a pipeline where the first it will get built and compiled, and also various kind of automated testing will happen. For example, we can integrate SonarQube, which is used to which is to validate the code. Or for example, if I'm having Python, then we can use PyTest. And if I'm having Java, then you can use JUnit for doing the automated testing. So developer now will not only focus on writing the logic, not worry about the testing part. It will happen automatically, and if there is any error or bug, then it will immediately alert the developer and all the team members in his group that something has been failing. And here you can see that we can catch the error in the earlier step, and not in the not after deployment. So it is yeah. And if everything is working fine, then it will hand up. Then there will comes a continuous deployment part where it will deploy the things to the environment. And we also have monitoring part, which was missing in the earlier process. So now we can monitor the things, how my application is behaving, and if there are any logs, and we can audit the logs, and we can diagnose and tune it, and we can get proper feedbacks. And in this way we can continuously improve our process, because now we are having continuous feedback pipeline. And now developer again start working on the feedbacks, and the whole process keeps on going. So this was all about the DevOps cycle. Now we will understand what are the business impact, that how it improved business to grow. this by using the DevOps. So now we can see the quality of the build can be improved now, because now developer will focus continuously on on writing a good business logic, and also various kind of code review can happen. We can also implement various kind of code review tools. And then we can also I know here we can identify the bugs as early as possible, as we saw in the pipeline, that if something is happening in here, we can identify the bug in the very early step, and the overall reliability of the product also increases. For example, now here everything is had to happen in an automated manner, so no hardly less manual steps are involved, so there is very less chance of the manual errors. And it all, the very important part we can see here, that the team collaboration that were missing in the earlier part, now it can also be resolved. Now we have because we have constant learning and improvement going on, and also the collaboration will also improve between the developer and the operation team. So as we discussed, that when a developer commits something on DevOps, it triggers a pipeline. So this pipeline we call it as a CI/CD pipeline. So what is CI/CD? CI/CD, here you can see it refers to two words, which is CI and CD. So CI refers to a continuous integration, which focus on continuously integrating the work of individual developers to a pipeline, and continuous deployment, it focus on the deployment part of the thing. Now we understand what are the benefits of the implementing the CI/CD. So we can see that now we can have deploy a small and frequent code changes, because all the things will happen at a very fast rate. And we can also roll back things easier. Now we are having a proper pipeline. If I have to roll back, just have to trigger a rollback. It will roll back to the stable version. And also it increases the proper transparency and the accountability, because if something is going fail, then we can get a proper alert on mail that that my code is or build is failing. Now we will understand the various tools around the code build. These are the tools available on AWS, which enables us to implement the CI/CD. So CodeCommit, AWS CodeBuild, and AWS CodeDeploy, and then finally CodePipeline. We will understand all this process, all the tools step by step. So now first I will start with AWS CodeCommit. So AWS CodeCommit. So it is it is like a private version control, which allows us to store our code on a cloud. So it is, so if I have to say, it is like it is like a GitHub, but it is managed by AWS Cloud, and it has multiple other features also. So for example, it supports encryption now. So because it is integrated with KMS, all my code that I store on AWS CodeCommit, it will be properly encrypted. And we can, so and if I have to manage the access part of it, then I can make use of the AWS IAM, and we can have unlimited storage of the code. And we can also enable the alerts part of this. For example, if someone is creating a pull request, or someone is deleting the branch, this kind of things, I want to also enable the notification part of it. It is fully managed by AWS. So now we understand the theory part of it. Now I will go to the demo part and explain how things will happen. So here we can see this is the AWS management console of the AWS CodeCommit, and it comes under the AWS developer tools, and all the services that we saw are available here. For example, this code build, code deploy, and code pipeline. So all are available in a single console, which is the AWS developer tools. So first we will start with the AWS CodeCommit, and this is the in this we have a concept of the repository, like a open source version control tool. Here this is the code that I have created for this demo, and we also have this readme file. And so first we will understand the alerting part that we discussed. So here you can see we have this notify. If I go here and create, so here you can see we can create alerts for various things. For we can go for various things. For example, we can you can see if someone is committing something, we can we can get alert for that. If some very important thing is here, the delete part. if someone is doing some delete in my branch, then we can also set the alert for that. And here in the target part, we can set SNS or the word Slack chatbot. So for this, so if I have to create uh, demo alert, and I select the type is full, and I'm selected that I want alert for this create. If someone is creating a branch or updating a branch or deleting branch, then I will get alert on this SNS topic. And if we click submit, and in the setting part, here we have notification where we can see that for this event, I will get a notification. Now we'll go through the other features which are available here. So the next is the commits. So here we have this commit visualizer where we can visualize that what are things happening in my in my branch. So here you can see that this is my master branch, and here someone has created a new branch, and at this step this has been merged with my master branch. So like this we can also visualize, or if I have to compare the commits between the various branch, then we can also do these things. We have next the branch part. So so if you have to explain the branch, what happens, we have one when we start a project, we start with one branch which will be the master branch, and for each feature, for example, I'm having website where I'm having one contact us about us. So these are suppose the features. Then for each feature we will create a separate branch and we will work on it. And then if something is tested properly, then we will create a pull request where I will tell the admin that merge this branch to this one. So like this we can make use of the branches. Now we are having setting part. So setting, we saw this SNS alert part. Now we also have the triggers here. So suppose I'm having a scenario where I want that if someone commits something on my code base, then I want a trigger to be updated. For example, I want a lambda to be triggered where I will do some validation of the code. For example, I will check where someone has hard coded some credentials like that. So that feature we can also enable here. So for example, here we can see we are having lambda. So we can see the events. For example, if someone doing some post to existing branch, then it will create a lambda function, and we will select the lambda that we want. So we have to create a lambda function, and then we can create a trigger that like that. And the most important part of the this code commit that it supports is this approval route template. Now consider a scenario where I'm having a code base and I want only a specific group of user. For example, I want only the tech leads to be able to merge to my master branch, not everyone. So for that, I will write a rule. So here you can see, here we will write a rule, and here we will add the members. For that, either we can use the IAM rule, or I can use the ARN of that. For example, if I am having one IAM admin user and I want this here, then only, and if I select a branch like I'm having one master branch, and for this repo SAA Bootcamp, what it will do, it will only allow the admin user to merge to this repo of the master in master branch. So in master branch, only admin can merge, not everyone. So this is also important feature from the security point of view. So you can see and only we can merge to we can do description, and we can create this. So like this, we can also create multiple templates. And next, from the pricing point of view, if I have to cover the pricings, and then we can see that from the pricing, the first 5 active users are free in this code commit every month. So the 5 active user will be free and to use the code commit every month. So will not be charged for that. So this was all from the code commit side. Now we will go to the next part, which is the code build. So code build. So first we'll understand what is build. So we talked about this build in multiple places today. So build is like so. For example, if I'm writing a Java code, then then we compile it, and then we get some artifact, which we call it a jar. So that we can consider as a build. Uh, like that. And this code build is a service which allows us to build our code, and also we can do this code build for doing the testing. That we will see how we can do this. So if I have to compare with the other tools, then we can say that it is like a Jenkins, which is the open source tool. Yeah. The code build has multiple features available, which is that it is completely serverless, so we don't have to create a cluster or launch an instance before working on it. So it is completely serverless, and it works on the Docker images. So it creates a container for each build and start working on that. Since it is, it's a serverless, that we don't have to worry about the scaling part also. And in this, the pricing is like that. We only pay for the build time. For example, my build is running for 2 minutes or 5 minutes, then I will only pay for that build amount. And for this build to work, we have to write some code. So that code we write in the buildspec.yaml file. So now we will understand the buildspec.yaml file structure. So whatever is given here, our code will process this. So the first part is the version. So version part here, it tells code build to interpret these commands in a specific manner. So for example, if I use version 0.1, then the then the interpretation will be different. So the current version is 0.2. We have various phases here. So the first is the install phase, where we write the command I want to install. So for example, if I have some Python package, then I want to install something, some packages, then we can write pip install requirement.txt part here, and it will install all the command here. Then we have the finally block. So this finally is like a try catch finally only, where if any of the command fail, this block will run anyhow, and we will get the message that something is failed. The next is the pre-build. So we have like a pre-build, build, and then post-build. So now consider I have to build a Docker image, okay, and then so what are the steps? So first step is to do a login, with the ECR, then build a Docker image, tag the Docker image, and in the end, what I will do, I will push the Docker image to the ECR. So for that, we can distribute this steps in multiple phases. For example, in the build part, we can first we can just get in the pre-build part, we will do the login with the ECRs, and in the build part, we will actually use the Docker build command, and we will build our Docker image, and we will tag it. So one question arises: why not to write all these steps in a single command? So for this, uh, so suppose if I'm doing this login part in the end. First, I build the Docker image. Then in the end, I will log in and then push. So what happens there? So for example, I'm doing this Docker build. It is taking around 2 to 3 minutes, and something fails there. And consider that I'm doing Docker build, and if something is working, if everything is working fine, and then I will go to the Docker login part, and I get some issues with the AWS IAM credentials, and it fails there. Then what will happen? That all my build time will get wasted. So why not test the credential earlier? If something has to fail, then it will fail fast. It will fail earlier. So like that, we will save our time. For example, if I start the build and in the very first minute I get the error that I'm missing some policy, that we can resolve that error here itself, and we don't have to worry about the other part. So like that, we can distribute, and here we can see in the post build we can do the Docker push part. We also have other two parts, which is the artifacts and the cache. So artifacts, so consider so we as we so this whole build, uh, it creates a container, and once that build is done, it destroys the container. So all the things that we have compiled so far, it will get destroyed completely. So if I want some things to be uploaded to some location, so that I can use in the next step, for that I have to create artifacts. So here, for example, if I have in Java, then we can create a .jar file, and I will store this to some location from where I can access it. So for then we can use this artifact section. Then we have cache. So consider in the install phase, I am having multiple things to install, and which takes around 2 to 3 minutes. And next time, and I want to cache that part, so that next time when it start the build, it will just take the dependencies from the cache, and it will not start installing all the things. So for this, we can also use make of cache. So yeah, this was all from the build spec YAML structure. Now we will go to the console and understand. So yeah, in the developer tools console management only, we can see we are having this build part where, yeah, this is the landing page of the code build. Here we can see pay only for the build we use. Yeah. So in code build, we have a concept of projects. So if I have to create some build, then first I have to create a project. So for example, I will click here and we will create a project. So what are the features available? So if I select so in this project, the first important thing is the source. So so we have to tell the code build that from where it will access my code. So in the source section, it is very important to understand that these are the source available here. So you can see either we can have S3 as our source. For example, if I have stored all my code on S3, then we can just give the bucket name and the path where my code is stored. I can have code commit as my storage. I can have also GitHub, Bitbucket, and GitHub Enterprise. So this code build also supports the open source tools. So it is also very important to know. The next is the code. So in this demo, we will take the code commit since we have created a AWS code commit repository. And in the repository, we will select the repository that we have created in the branch. So we can select multiple things for the source in the reference one. So for this, we will select this master branch yeah, in here. So as we discussed that this contains a Docker image here. So we can either use our custom Docker image, or we can use the Docker image which are managed by AWS. So for the custom, we can select the various environment type. For example, I'm having machine learning things to be built, then we can use Linux GPU. And we can also store our Docker image on ECR, or we can also use the Docker Hub or other open source repository. And then we have to give the credential and it will work. So for this demo, we will select the image managed by AWS, and we will select. We have multiple options, like we can have Amazon Linux 2, Ubuntu, and Windows Server. We will select Ubuntu. For the runtime, we will select the standard. For the image, we will select the current one, which is the 5.0, and version will be the current one, latest. Environment type, we will select Linux, not GPU one. Here we have the privileged one. So suppose all the files that I have in my build spec, I want to run as a root user. For that, we can also select this privilege. If I tick this one, then all will run as a root user. Then we have to pass one role. Either we can create or you can use the existing role. So for the existing role, I've created one. And yeah, so for this role to work, we need access of this source, which is the code build, so which is the code commit here. And yeah, the next important part is the build spec. So as we saw in the build spec template structure, so either we can give the build spec file path, or we can use we can write the code here only. So if I want to write, so here you can see this is the structure that we saw in the YAML structure, and we can either write our code here, or we can store our code to some location, and we can just simply give the path. So one question arises that the file name should be the build spec, or we can have a separate file name, or where should I store this file? So here you can see if I'm storing this file to some separate location, then we have to give a proper path. For example, if I'm storing in configuration folder, then I have to give this the path as a configuration slash buildspec.yaml. But in our case, here we can see Yeah. So here we can see this is my build spec file, and I have stored in the root of this my. So yeah. So here we will simply give the name as buildspec.yml file, which is stored in the root directory. Now we will go through the buildspec.yml file that we will be using for this demo. So first we are having this version, which is 0.2. Then we have phases. And in this install phase, I'm installing a Node.js, which is of version 12. In the pre-build, I'm just simply writing a echo printing. And in the build, I'm just trying to mock validation, which is it will check whether welcome to SAA Bootcamp is present in this index.html file or not. If it is not, then it will throw error. If it is, then it will succeed. So now we will go to the index.html. So here we can see we are having one index.html. In the body part, we have this welcome to SAA Bootcamp. So when it will check and it will search the string in this file, it will get and it will succeed. So yeah, now we will come here. Yeah. So the other two part that we discussed about the artifacts and the cache, we can also see here. So in this part, we saw one thing that if I have to upload the artifacts, upload this jar file, the path we are not giving here. So where can we get the path? That where to store. So here we can see that in the artifacts we are having storage location, which is a Amazon S3. Here we can give a configure that where I want to store this artifacts. So like this we can do this. We also have this cache that you saw here. For the cache, same thing. We have not given any path where to store. For that, we have to configure this in the build while creating the project only. That here we can also set the path S3 as our cache type, and we can select the bucket and the path where I want to store, like this. And the next part here is the logs. So logging is yeah, you can see that we can have we will send our log to CloudWatch or to S3. So logging we will understand in great depth in the upcoming slides. But for now we can understand that we can send our logs to CloudWatch or as well as to S3 for storage like this. Now we will simply create a bucket. With artifacts. Yes, it. So now we will start a build. Since we have not integrated this with code pipeline, we have to manually trigger it. But once we trigger add this with code pipeline, it will get triggered automatically. So we have this phase part where we will see all the phases that we have configured in the build spec file. So currently we can see that it is submitted, queued, and Docker container is getting provisioned. Now the Docker container get provisioned in 18 seconds. Now it is downloading the source code from the source, which is the AWS CodeCommit in our case. And here we will see all the logs when it will start deploying. Now yeah, so now here you can see for all the step we are given the succeed part. So here we see that install, pre-build, build, post-build, all the phases that we configured are displayed here. And in the logging part, we can see that Node.js 12 version is got installed, and code validation is going on, and it found this string here index.html. So my overall build, we can say that it has succeeded. So like this. So this was from the code build part. We will again go through this in an automated manner in the code pipeline. So for now, yeah. Now we will go to the next service, which is AWS CodeDeploy. So CodeDeploy it also comes under developer tools, which allows us to deploy our deployment automatically to EC2, Lambda, and ECS. So for example, if I have to deploy something directly to EC2 or Lambda or ECS, then we can use this CodeDeploy. CodeDeploy, the very important feature of this CodeDeploy is that it supports the hybrid model. So what is this? So if for example, if I have some instance on EC2 AWS account and cloud, and some instance on the on-premise, and I want to deploy the same things to both of them. So for that, we can also use this CodeDeploy. We will understand how it will happen. And yeah, it is completely secure, and it is also fully managed by AWS. And for this to work, we have to write the code in the app spec file. So for code build, we had buildspec.yaml, but for code deploy, we have appspec.yaml. So it may be quite confusing to understand, but yeah, so we have to focus on this, the names. The other important feature of this code deploy that it supports automated rollback. We will also understand this part in the demo. The one note is here that code deploy does not provision any resource. For example, I have to deploy something to EC2 or to Lambda. Then code deploy will not create Lambda for me. That Lambda has to be created, or EC2 instance has to be created. It will simply deploy to that. So that we also have to remember. Yeah. Now we will understand the working of the code deploy, how it works, and how it deploys to my EC2 and on-premise. So for that, it works on a concept of agent. So for that, we have one code deploy agent that we have to install first. So for example, if I am configuring EC2, then we can write a startup script where we will install the code deploy agent first, or on-premise machine. Then this code deploy first send this appspec file to each machines which have been running the deploy agent. Then these machines will deploy the application based on the code that we have written. And if anything fails or succeeds, then again it will send the response back to the code deploy. So like this, the communication happens. Code deploy also supports the two types of deployment. So here we have one is in place, other is blue green. So what is in place? So consider I'm having some application deployed, which is version 1 of it, and we are having one load balancer. We have three instances, 1, 2, 3, and all are having version 1 deployed on it, and my traffic is getting shifted in this manner. Now I have version 2 also. I want to deploy. How can I deploy? So if I select the in place, then for the in place, first I will take the version 2. So in this, I will take one instance of, down, and I will install the version 2, and then again I will make it online. So at a given point of time, the traffic will be only shifted to less instance. For example, I'm having three instances in my pool. Then if I do the deployment, then only two will be available, and this is not good for the production account because the performance will get degraded. So this is not recommended for production, but for development and testing we can do this. So the most recommended way of doing the things is the blue green deployment. So what is this? So in this blue green deployment, what happens? It creates a exact copy of my existing environment, like this one, and it installs a new version on it. For example, now version 2 is deployed here, and once everything is working fine, then I'm having one router. For example, I may have route 53, and it will just simply point from this pointer to this pointer. Now my traffic will come here, and router will divert to this point to this one. And if everything is working fine, then we will destroy this environment. And if something if something fails in this new environment, then we can simply tell our route 53 to point to the old one, and we can start debugging this one. So in this, we can see that we are having very less downtime, or mostly no downtime. So this is most recommended one for the production. So this is also supported by CodeDeploy. Now we will understand the app spec YAML structure of this. So yeah, we again have the version part, which tells our code deploy to interpret the file in given order. We can we can select the OS like this. We can have Linux and all we want. And then we have this file part. Consider I have to consider. Sorry for this. Yeah. Now consider I have some file in my root directory, and I want to copy from one location to other location. So for that we have this file section. And next we have this. So in build spec we had these phases, but here we have these hooks. So it's also very important to remember. Uh, uh, Next we have this. So in the hook part, we can see we are having this before install, after install, application start, and application start. So for all these hooks, we have to write we have to give the path of the scripts. For example, what will happen in before install. For example, I want to install some packages. So for that, I can give a path that where my this all the installed dependencies package are located, and what is the timeout for it, and how I want to run as a root or as a normal user. And if after and if for example, I have installed all the packages, now I want to change the permission of that. So that we can do in the after install phase. And similarly, we have application start and application stop. We will go through the code of this also. We have this flow part here. So we have two scenario. The first one is this code classic. So if I have load balancer in my code deployment, then the deployment happens in this way. And if I have if I don't have any load balancer, then it will happen in this way. If I having a load balancer, then it will follow this path. So all the things which is in gray, for example, start, download bundle, install, and for this we can write the code for it. So here we can see the hooks that we have. So all the one which is in blue, we only write the code for that. So all this will be gray and managed by AWS in the backend. So first, if I have to deploy something, it will stop the existing one. It will download the new bundle, then it will install the packages, and then it will configure the packages like after install. Then it will start the application and it will validate. And if I have any load balancer in place, then we have 6 additional steps. So you can see the first 3 are here and next 3 are here. So what happens in this? So all the traffic related things like before traffic and after allow traffic, this kind of things what it does. So in this, the instance which are a part of my load balancer, which will get removed from the existing pool, and in the last phase when everything is installed, it will again become a part of my load balancer, and the traffic will start flowing through it. So this is the flow. Now we will go through the console part of this code deploy. So again, we find the same code deploy in this console. Yeah, this is the AWS management console of the code deploy. Here we can see. So in code build, we had a concept of project, but in code deploy, we have a concept of application. Because in the end we are deploying an application. That's why. So here we will create one application. For example, I have to create. And in the compute platform here, you can see that we have 3 options that where I want to deploy. I want to deploy to EC2, I want to deploy to Lambda, or I want to deploy to ECS. So like that we can configure. So for this hands-on, we have created one. So here we can see the type is of EC2 premise. And once we create the application, then we have a concept of this deployment group, where we will create a deployment group. In this deployment group, we simply configure what is the role I'll be using, and which instance I want to tag in. So for example, you can see one thing, that we have 2 types of deployment, which is the in place and the blue green. So we all discussed that in the presentation. Now this is the configuration part. So how my code deploy will know that where I have to deploy the deployment. So for that, we can either select auto scaling group, or we can select EC2 based on the tags. For example, I'm selecting so I'm telling my code deploy to consider all the instance which having env as a develop. So here, if I come here, we are having one instance where I have given a tag of env of develop. So in this case, so in this way, so here we can see that one unique mesh instance. So since I am only have one instance with this tag, that's why our code deploy come to know that this particular key value matches with one instance, and it will deploy to this instance only. For example, if I want to deploy to some other instance, for I'm having one other env as a prod, that we can also configure and create a separate deployment group for that. So this was the things I wanted to highlight. And once we have created application and then we have created a deployment group, then we will simply create a deployment. So, and when we create a deployment, we will see that our site will get hosted. For example, I have deployed a simple site, and we will go through the code of it. So this is the index.html that is we can see here displayed, and this is the body of this, and we will see the app spec file of it, what it's doing. So in the app spec, we can see it is copying this index.html that we saw to this location, because we are having Apache server and we are having these hooks. And for these hooks, we are storing our scripts on this location, which is scripts folder. And now we will see the script folder. Yeah. So for all the hooks, we are having all these scripts stored here. So for example, I want to see what I will install phase. So here I'm just installing a yum install httpd, which will install the Apache server. In the start server, we can see we have service start httpd start, which will start our server. Similarly, in the stop, we will check if my server http is there, then it will just stop it like this. So in this way, we can deploy our deployment to the EC2 instance, or similarly in Lambda on ECS. So now we covered the code deployment part. Now here comes the very important service. So which is the code pipeline. So code pipeline, if I have to say, it orchestrates all the services that we saw so far, which is code commit, code build, and code deploy in a single string. So if I have to, so here we can see that this is my code pipeline, and all the services, source, build, test, staging, production, all are integrated with this. So how it works? So we will see that. And from the pricing perspective, if I have to say, then we have to pay only $1 per pipeline per month. So this is the concept. It also gives a visual workflow that we will see in the demo part. Next, we have the code pipeline working. So how it works? So code pipeline. We can say the backbone of the whole code pipeline is the shared S3 bucket, where for each stage, for example, we are having three stages, which is source, build, and deploy. So for source, it will output or dump the artifacts to S3 bucket. Then the next step for this build phase, this output will become the input. It will take this input, start building on it, and again after doing the build, it will store this in the S3 bucket. And for the next step, which is the deploy, it will take this as an input and start deployment. So for all this is there is some shared S3 bucket that we'll again see in the demo part. So here we will, yeah. So here we will see the code pipeline. Yeah. So we will create one code pipeline. Yeah. So first we have to give the name. And we have to give one role. So this role needs access of all the things that we saw so far, all the services. And then comes the things that we discussed. So here we saw in the working part that we have to give the S3 bucket, which is this one, that where I want to store the intermediate artifacts. So either we can select default location, or we can give a particular S3 bucket that where I want to store. For example, I want to store to this location, then we will give the bucket name. For the encryption, we can have the default AWS encryption, or we can give the custom encryption key managed by us. Next we will select the source. So for this code pipeline to work, we have to give a source, and then we have to also give the build and deploy stage. So here we will see. We can see here that we are having multiple options available as a source. We can have AWS CodeCommit as a source, and it means that my code pipeline will take the code from this location and give to the next step. Or we can have ECR as our source. We can also have S3 as our source. It also supports Bitbucket and GitHub. So yeah, it's all options are available. So for this, we will select code commit. This is the repository that we have created, and this will be the branch. Yeah, we have multiple options here. So how my code commit comes to know that something has been, I mean, some changes had been made in my code commit repo, and I have to start the pipeline. So for this, in the backend, this code pipeline uses this CloudWatch event. So we will understand this CloudWatch event and its importance in the upcoming slide in the logging and monitoring part. But for now, we can see that this option is available and it is the recommended way. But we have also other option available, which is the code pipeline. But this how it works? It checks the changes in some equal interval. For example, in every 10 seconds or 20 seconds. So it will not be a real time. So for the real time changes, we follow this one. Then we can also select the artifact format. For this, we will select the default one. Now we have the next stage, which is the build stage. So for build stage, we can see either we can select the code build or we can select the Jenkins. So Jenkins is also directly supported here in the code pipeline build stage. So for this demo, we will select this one. Then we will select the project that we just created, that we had created, and then we will just click next. So yeah, in the deploy part, we also have multiple options available. So we saw one thing that in code deploy, if I have to deploy to EC2 instead ECS and Lambda, those three options are only available. But what if I want to deploy to EC2? What if I have to deploy to CloudFormation, or I have to deploy to Elastic Beanstalk, or I'm having a static website and I want to deploy to S3. So that options are available in the code pipeline deploy stage. So yeah, for this hands on, we will select code deploy and we will select the application, and this is the deployment group we had created. Now we will click next, and here we can see that in the end we will get something like this. So yeah, so for this hands on, we have created one pipeline. So once that is triggered, it looks like this. So here we can see it is like a pipeline and continuous things. So once something gets triggered, source gets triggered, it will start the build phase and it will start the deploy phase. But one thing is missing here. So for example, in this scenario, we can see that if something gets uploaded to my source, which is code commit, then it will start a build. That is fine, but it will automatically deploy to my deployment. For example, I'm having production server here. It will directly deploy. So this should not be the case. So ideally, what should happen? Uh, there should be source, there should be build. Till dev and UAT, it should deploy automatically. But for production, I should have some step in the middle. For example, uh, we can add one manual approval step here, like this. So here you can see we can add one additional stage. We can add this manual approval, and in this we can add one action groups, which will be approval. And in the action provider, we will select the manual approval. So what this will do? Manual approval. So now if something gets my source gets triggered, it will start the build part. But before deploying, it will ask for confirmation whether I'm okay with this deployment, and I want to with this validation, and I want to deploy. So it will add an additional check. So this is also very important. So for this demo, we will make some change to this code, to this index.html. For example, AWS DevOps, we should write 8 like this. And here you can see that we have the transparency part that we discussed. We will write that who is the author here. And getting so now we will commit the changes, and now once we commit the changes, it will trigger my code pipeline. So we will come here and see that my code pipeline is now in progress. So here you can see I simply made a change in my code base and it triggered a pipeline. and we can see the comment that we added. So now, just now, it has got the source code. Now it is in build phase. So if I click here, I will see what all things happening in my build project. So yeah, you can see the same thing. All the stages are there, and now you can also see the logs for this. Yeah. So in this case, this word is still there. So my build has passed. Now we will also see uh, the additional stage. The additional things are here, which is we can also see the various CPU and memory utilization, this kind of things, and the build details. And now if I go to code pipeline, if I do refresh, yeah, here you can see the build has succeed, and now it is stuck in this part in progress. Now it will ask for one approval part here, and then only it will deploy to this part. Yeah. So here we can see I will click. I will either I will approve this build or I will reject this. So for example, if I reject, then my pipeline will stop here. But if I approve this, then it will get approved. So I will write a message like looks good. Okay. Now you can see we have approved, and we can also see one thing, that who has approved. With this kind of transparency, we can also see that user SAA has approved this and what are the comments I have written. Now it will go to this uh, deploy phase. Yeah, so now you can see now my deployment is happening here. And now if I click here, and we will see all the events. Yeah, these are the hooks that we saw, and it has deployed my new changes to this part. Now if I go to this and if I do refresh, I should make things. So here we can see using this CI/CD, how my things and how easily we can deploy things in a very quick manner, and how small and frequent changes and all those benefits that we discussed so far, we can implement this. So this is all from the CI/CD part. Yeah. So before going to the next part, is there any questions so far? Mm, I will take this as yeah, I will take this as a no. Yeah, I will go to the next part. So the next important part is the AWS CloudFormation. So what is CloudFormation? So it comes under infrastructure as a code. So infrastructure as a code, if I have to explain, so now consider a scenario where I have to where I have to deploy one application on EC2, for example, Node.js application. But for that, I have to create multiple services. For example, I have to create IAM role, I have policies, EC2 instance, security groups, and all these things. So if I have to deploy these things, I have to go to console and I have to create all the things manually there. But if what so somehow if I do something for one environment, which is the develop one, but if I have to do the same thing for all my accounts, for example UAT, production, stage, then I have to do the things same things 3 to 4 times, and again manual things, I'm doing things manually. So multiple type of error will come, and if I have to update something, then again I have to follow the same path. So will it be great if there is some code that I have to write, and I have to simply deploy that code somewhere? So for that, CloudFormation came to the picture, where we will simply write the code and we will deploy, and using that code, it will create the whole infrastructure that we need. So it comes under infrastructure, and so the major benefit of this, that within a single click, we can create or we can destroy our whole infrastructure, and this supports the YAML and the JSON. So that. So now we understand the template structure. So for this also we have to follow some pattern. So this is the version that I have to follow. Then we have a parameter block. So if I don't have to hard code any value, that we can simply give this in the parameter part of it. So out of all the blocks, the major and important block is the resource part. Yeah. So the very important part is the resource So all these are optional, but only this is the compulsory mandatory field that we have, that this should be present for our CloudFormation to work. So we will, yeah. So CloudFormation supports various features. For example, it supports conditions. So how condition helps us? For example, I want to deploy some. I want to create some EC2 instance or something, but this should be created in, for example, prod environment only, not in dev environment. Or for example, I want to create a EC2 instance of type t2.large in prod, but on t2 small in lower, in dev and UAT environment. For that, we can also write a condition like this, that if this matches, then only it will create. So like this, we can implement. Then CloudFormation supports mapping. So mapping is like a, yeah, so we can say mapping is like a lookup table. So as we all know that the AMI ID of all the EC2 instance changes based on the region and the architecture. So for 32-bit in US East 1, the AMI ID will be different. So for that, we can use the mapping where we will store the AMI ID. We will and we can use this in our code using this function, which is find in map. And based on the architecture, for example, the output of this block will be, for example, if I'm having US East 1 here and I'm having 32-bit here, then what it will do, the output of this block will be the US East 1 and 32, so it will become AMI 64111E2 OD. So the image ID will become this one. The AMI ID will outcome in this format only. So these are the separate features. Now the next one is the function. So the one function we saw here is the find in map. The yeah. Now we also have multiple other functions. For example, we have join here. We can also implement. We can also join multiple strings together. We have select, like based on the index. We can select the index from the list. Then we can also perform split. We have the reference also. We also have this import and export features. So yeah, it is also very important. So it's also important to remember that CloudFormation supports multiple functions. Next is the CloudFormation stack. So in CloudFormation world, we have a concept of stacks. So all the code that we write in the template, so all the combination of the AWS services that we write in a template, we call these as a stack. So yeah. The next very important feature of this CloudFormation is the CloudFormation nested stack. So now the same example that I gave earlier, that I have to deploy a Node.js application on EC2, but earlier we were doing this manually. But now if I have to follow the CloudFormation path, that there are two ways again here. First, I will write all the code for all the resource in a single file. For example, I will write the code for EC2 instance, security group, IAM roles, everything in one single file. But it will become very difficult to manage. So the other way of doing the things is to modelize the thing. So I will write all the resource related to the IAM in one stack, and then all the resources related to the VPC, like security group, subnet, it will be in this, and all the resources like EC2 instance and will be in separate group. So now if I have to manage or update something or change something, it becomes very important. And we will simply import and export the parameters and the values from one of the stacks, and it will start working. So now we will go through the demo part of it. So uh, this is the management console of the AWS CloudFormation. So for CloudFormation, the pricing is like that. It is completely free for us to use. For example, if I'm creating some resource from the CloudFormation like Lambda EC2, then I'll be only paying for that resource, not for the CloudFormation, not for the using the CloudFormation. So it is completely free to use. And in this, we saw that we have multiple options available. First one is stack. The most interesting feature which is available in the CloudFormation is this designer. So here we can see, yeah. So here you can see we are having JSON and YAML structure available. Or these are the all features that we discussed, mapping conditions, and in template. So now consider I have to deploy a lambda function. Okay, so I will come here, and I don't know how to write the code for it. Then I will come here. I will simply do a drag and drop here, and here we can see that we will see the we will see the starter code, a boiler code for the lambda function, and we can start configuring the lambda function properties. So like that, if I have to create some other resources, that we can start from like a drag and drop, and we can start writing here only. So this is also very good feature of the CloudFormation. So now we'll go to the stack. So in this demo, uh, we will be creating a lambda function. For that, this is the template that we are having. Uh, so yeah, so the first is the version of this template. Then we are having parameter. For this, we use the organization, and we can also write the default value for it. So yeah, this is the default value. Yeah, this is the important block, the resource one, because this is the compulsory out of all the blocks that we see here. Now I'm creating a lambda role here, for example. So the type, it will become AWS IAM and role. And suppose if I have to create a user, then the type will become AWS IAM user. So like this, we can configure the type. Uh, and these are the properties. So it contains all the properties that we can do through a console. So for example, when we create the role through console, we have to give the no we have to give the name of the role. So that we can also see here, this is the name. Then we are attaching this role to this the trusted user of this will be the lambda function. So the principal is the lambda, and we are giving the policies like of S3 access, and then CloudWatch logs, and then SNS. And now we are creating a lambda function. So here you can see the type is AWS lambda function. So in this way, we are telling our CloudFormation to create a lambda function. And in the properties block, we have all the additional we have all the features that we can also see through the console. For example, the function name, the handler part, the RAM memory size, also timeout, also the role. So for the role part, we can see that role we are creating here in this here, and we are referring this in here using this get attribute function. So yeah, so that's why the functions are also very important while working with CloudFormation. Now we are having the runtime as a Python 3.7, and we are having we are writing a simple code. So either we can write a code tightly here, but there is some size limit, or we can upload our code to S3 bucket, and we can simply give the path here like this. The other block that we have here is the output one. I want to see the ARN of the lambda that I'm creating in my CloudFormation. That is, what is the ARN? Or for example, if I'm creating EC2 instance, then or I'm deploying something on it, then I want site URL or the domain name of that. Then for that, we can also write this in the output block like this. Now we will come and create a stack. So when we go to the stack part, we will see we have three options here. The first one is the template. Either we can write our own template, we can use a sample templates, which is the WordPress LAMP stack, these kind of things. Or we can start we can create our template in Designer, and we can deploy from there also. So for this hands-on, I'm having this template I'm having here, and we can for this CloudFormation to work, we have to either upload the template to S3 URL, or we can simply store from our local. For example, in this case, I'm uploading from my local device, which is here. But in the end, it will upload to some S3 bucket only. So here you can see the S3 path of that. Then we will click on next. Then we will give a name. In the parameter part, we see so in the code we gave one parameter, which is of type organization. And for the default value is this SW Bootcamp. So here you can see it came here. But if I if I want to change something, that we can also make something change, and it will override the default value. So like this, we can also configure this. Next is the tag. Then we have permissions part here. So how it works? So either we can give the name or the role for this CloudFormation to work, or if I don't give anything, for example, I'm not giving any role or ERN, then how it will do? It will assume the role of the user. For example, currently I'm logging as SAA, then it will assume the credential, policy attached to this one, and it will configure like this. And then we have a stack failure options available. For example, then so here we have two things. So consider I am deploying something, and if something fails, then I want to roll back all the changes to the stable version, so that so that all things are working. Or if I want to do some debugging, that why my changes, why my infrastructure failed. So for that, I can select this option, where it will preserve the resource which have been successfully created. So that in this way we can also do, it also handles the failure part. In the advanced options, we are having this stack policy. So stack policy is very important. So it is like we can say the bucket policy, but the format is quite similar, but it is used for unintentional updates. For example, if I'm having RDS or my cluster, my DB deployed in live production environment, and if someone updates something by mistake, then there will be a chance that it will accidentally it will delete the whole cluster, RDS cluster, and my all data will be lost. So for that, I will simply write a policy that who can update and like this. Then we can also configure the alert like SNS, that if my this stack fails, then I will simply get a notification. So for this, we will create, and see here we have to, in the capability part, since I am creating one IAM role in this template, I will have to click yes. And here you can see that in the, we have this stack info, then we have event, and in the event, this is creating one lambda role. And here we can see in the resource part, this is create in progress. And if I come here, then we will see that it has simply created a new IAM role for us with the three policies that we have configured. So using this CloudFormation, we created a IAM role, and we will simply see also that it has also created a lambda function for us. And this is the code that we had given here. See, so it has deployed our code also. And in the config part, we can see that this is the memory that we had given, which is 128, and this is the timeout, which is 90 seconds. So like this, we can see that if I write the code and I want to create infrastructure, it will be very simple. And if I want to update something, I will simply update, and I will just click on this update part, and it will update for me. And if I want to remove, if I want to destroy the whole infrastructure, then I will simply come here and I will click delete, and it will delete the whole stack for me. So so in the presentation that we saw, that with one click, I can create or destroy. So yeah, we can understand these are the features available with the infrastructure as a code. All the resource has been completely removed, delete completed. So yeah, that's all from this CloudFormation part. Is there any question so far? Please feel free to ask your questions in the chat. I will answer. Okay, yeah, I will. So I will go with the next part. So the next part is this the logging and monitoring. So logging and monitoring are the and most of the are the most important part of the project, but these are the also most underrated or most underestimated things when we deploy an application. But it is also very important to understand there's that in production environment, These are the only source of information. For example, the dashboard that we create based on the logs are only source of information for us. In production, we cannot simply, and not anyone can log into the production account and check the logs there directly and how things are happening. So yeah, so here we can see why logging is so important. That what this application is doing. If I have to understand, then it's important to write proper logs and visualize it. So yeah, so for logging, we have this CloudWatch log AWS service, which allows us to write and debug our application. So how CloudWatch log works? That for each service, for example, for Lambda, for EC2, we have a separate log group, and all the logs related to that service will be stored on that log group only. If we can also query our log, for example, using some query, we can also we can query and analyze how my application is behaving. We can also configure various alarms on top of it. For example, if I get a 404 message or like this, we can also configure various alarms. And and if I want to gather the application logs, for example, most of the time we are mostly focused on the infrastructure logs like CPU utilization and memory uses. But if I have some application deployed on EC2 and I want the application logs like how signing, login, this kind of things are happening, uh, then we have to configure one CloudWatch agent on the EC2 instance, and from there, agent will send the logs to the CloudWatch console, and then these logs will also be encrypted using the AWS KMS. So now we will go to the CloudWatch logging part. So all the logging and monitoring things that we saw, it comes under the umbrella of CloudWatch. So here we have multiple services available. So in this first we will understand the logs. So here we can see we have a concept of log groups. For example, for Lambda, we are having this log group like this. For Lambda, yeah. So we can see we are in this log group. In this log group, we are having log streams. So for each execution of Lambda, we have a separate stream, so like this. And yeah, and we can also have this KMS ID. Using this, we can also encrypt our logs. So we can also secure this whole logging using this. Then we also have one important feature which is the subscription filter. So what happens? So you consider I want my this CloudWatch log to be streamed to some Elasticsearch, or to send the log from this log group to Lambda or Kinesis Firos for analysis. That we can also do. So how it will happen? We have to configure a subscription where first application will send the logs to CloudWatch, and CloudWatch will in real time stream the logs to my target. For example, these are the targets available here. So using this, we can also configure the subscriptions. So if I have to check the log, how it looks. So the log, we can see all the things. For example, for the code build, we can see these are the options available. That enter the stall phase, and yeah, what are the things that we have printed. We also have one important thing that we can also query the log. So yeah, so if I go to log insights, using this we can also write a small query and we can run this. For example, this is a sample queries available. For example, I will have Lambda and I want to find that which is the most expensive request that for which I have been charged for more. For that, we can simply write this query like this, and it will give the that for which execution I have been charged most. So like this, we can also query and analyze. So excuse me. So yeah, this is the all feature which are supported in CloudWatch log. Next, so now we will move to the next monitoring service, which is the CloudWatch metric. So CloudWatch metric is like a value. When we store the values and it evolves over time, then we can also visualize it. So if you have to define a CloudWatch metric, you can simply say that it is like a time-ordered set of data which we publish to CloudWatch. For example, if I have to see that what is the CPU utilization of my EC2 instance over last 10 days, or so this kind of thing, or if I have to check how many invocations my Lambda have been, and what are the, I mean, how many current executions, and how many durations my Lambda has run. This kind of metrics if I want to check, then we can also then we can use this CloudWatch metric features. This CloudWatch metric has two types of monitoring, which is the first one is the basic one, which it collects the data. It collects the data from the service every 5 minutes, and the next one is the detailed one, where we have to pay additional charge for it, but it collects the data every 1 minute. From the pricing side, we can see that first 10,000 metric we have to pay point 30 dollar, and for the next we have to pay in this manner. So from the pricing side, we can also see it is very not so expensive. Yeah. Now we will go to the CloudWatch console. So for the metric, the, again this is the management console. We are having this all metrics which are available. So for all the services, we have some by default. We have some default metrics available. But if I want to create some custom metric, then we can also configure and create it. For example, if I am EC2 instance and I want to check the metrics of it, so for that I will come here, and if I want to check the suppose CPU utilization, here we can see I want to check the CPU utilization of this instance, then we can see that over the time, this is the behavior of my CPU utilization of this instance. So, and if I want to check some other metrics, for example, I want to check the disk write, and I want to check the credit usage. So these kind of things we can also analyze and visualize here. And using this metric, we can also create a dashboard here. So AWS also supports, I mean, very good looking dashboard. So for example, I've created this one where we can, simply combine multiple metrics like this. We can also select the theme, and we can collect or we can analyze metrics of all the services that we have and analyze in a single dashboard. For example, I want to combine EC2 instance, Lambda, S3 metrics, and single screen. We can visualize this also. So it will give a very good idea how my application and the infrastructure is behaving. So yeah, it's also very critical and in an application. The next, so this is from the metric part. Now we will understand the CloudWatch alarm. Yeah. So CloudWatch alarm. So as the name says, it alarms us about the events happening in my AWS account. For example, if something, for example, if the CPU utilization of my EC2 instance goes above a threshold, for example, my threshold is 80%, it goes beyond it, or my storage, it also goes beyond 80% or something, then I will get an alarm. Or if something is failing in my environment, then I should get notified so that I can take some action based on that. So for that, we have a CloudWatch alarm also available. CloudWatch alarm, for this we have three states. The first one is the in alarm, and the next, so whenever a threshold is met, it goes into the alarm state. So this is the in alarm state. Next one is the insufficient data. So when we create CloudWatch alarm for the first time, it first goes into this state whether and where it gathers all the data from the application behind it, and once it is done, then it goes to OK state. And when something threshold meets, it goes to alarm state. So these are the states. Then we have actions. So consider I got a CloudWatch alarm that the load on my EC2 instance is increasing. For example, I'm having some festive season going on, and I know the load will increase. So for we can also configure some actions on this. That if CPU utilization goes beyond 80%, then attach a new instance to the auto scaling group. So like this, we can also configure. We can also take the actions on this. So that we will see the demo part. So here we have the alarms, and we are having this in alarm. You can see. So currently there is no alarm, which is in this step. Then we have this all alarm where we can see that insufficient data. Okay, these are the state that we discussed. Now, if I have to create alarm, then we have to first select a metric that this alarm will monitor which metric and how it will come to know that something is happening. For that, we will select, for example, if I select EC2 and instance, and then if I select this one, let's CPU utilization, and if I want, and we can see the how I want to analyze the statistics. For example, I want to check the average of last 5 minutes. I want to check the maximum. So this can we can also configure. For this, I will add this, and here we can write give a threshold. For example, I want. So when the CPU utilization is above 70%, here we can see we got a threshold line here. When it will cross this line, our alarm will this alarm will get into in alarm state, and we will create a next, and then it will asking that when this goes to in alarm state, then what actions should be taken. For example, we can select we can select a SNS topic that send a message to this one. For example, if I select this topic, and then we can also apart from getting a notification, we can also configure actions that we discussed. For example, I want to add some EC2 instance to this auto scaling group, or for example, if I'm having EC2 instance and I want to perform these actions. For example, I want to stop the instance, or I want to terminate this instance if something is going bad in my instance, or I want to reboot. So this kind of EC2 actions are also available as actions. So in this manner, we can get notified, as well as we can mitigate the things that we can take the actions based on the alarms. So yeah. The next one is the billing alarm that we also have to understand. So consider now we can see we see the billing alarm now. I'm in North Virginia, but if I change this to any other region, for example, I'm to change to Ohio, then we will see that this billing alarm is gone. So this billing alarm is not available here. So from yeah, so it's also important to understand that billing is available in the North Virginia, but it works for all the account. So we can create this in this account this region only, but this works for all the account. This works for all the services in my account. So for billing, I can also add a threshold. For example, yeah, I can go to billing and I can select this one. That whenever billing goes beyond $100, for example, if it is goes beyond $100, then it will send me alarm that I am going over budget. This kind of things we can also configure. So from this we can understand that CloudWatch alarms are very important. And another use case of the CloudWatch alarm, we can do this is the yeah. Give me a moment. Yeah. So now if I've configured the alarm, now I'm having a EC2 instance where I'm having some security group. I've configured some rules on it, ingress rule and egress rule. And if someone changes the rules here, for example, changes the SSH configuration and the port access, in that case, my alarm will get triggered. It will send a message to SNS, as well as it will also trigger Lambda, which will again update the security group to the default settings. So in this way, we are first we are getting alarmed, and we will get notified, as well as we are mitigating the risk that happened in my account. So so using alarm, we can also do various kind of automation. The next service is the AWS CloudWatch event. Sorry. So excuse me. Yeah. So CloudWatch event. So earlier it was known as the CloudWatch event, but now the name has been changed to EventBridge. Yeah. So what it is? So CloudWatch event is a service that keeps on monitoring all the services in my account. That if any changes happen in the state of my service, for example, I'm having a code pipeline, and if the state of the code pipeline changes, for example, it is in the in progress stage. Now it has gone to failed stage or succeed state. Then it will this CloudWatch event will come to know that something state has been changed. So and using this, we can write various tools, and we can we can automate multiple things. For example, we have one source will be there and one target will be there. For example, if something happens in my code pipeline, for example, if my code pipeline fails or if my code pipeline succeeds, I want some other service to be triggered. For that, we can also for that we can use the CloudWatch event. So it will be better understood with the demo. So we will come here and we'll go to there. So the in the CloudWatch console, we can see the event part is there, but when we click on tool, yeah, here we can see it is going telling us to go to this new one, CloudWatch EventBridge. Yeah. So here we can see this is the console of CloudWatch EventBridge, and it has a concept of rules where for each configuration we will write some rules. For example, uh, I want to trigger my lambda. For example, I want to trigger my lambda every 5 minutes. Okay. Then for that, I will select this one, or I can write a cron expression for that also. And in the target, I will select, multiple service. For example, I will select a lambda function, and I will give a name. For example, this one. And if I come and create, then my lambda will be triggered every 5 minutes. So if I have to achieve this kind of automation, then we can also configure. And the other thing is the event pattern. For example, if I want to do something based on the action of some other service, for example, if something happens in my service A, then it will trigger some service B. For that automation, we can also configure this CloudWatch event. So, so for this, we will select the event pattern. Then we will select this predefined pattern by service, where we can select the AWS service, or it will also monitor the other third-party service. For example, we can have multiple services like we can have Atlassian, we can have Zendesk, and yeah, Stacks. So these are the third-party softwares which CloudWatch event also will monitor if we can configure it. So for this, we will select the AWS, and I will select a code pipeline, for example, and you can configure it that if there is any state change. Now, if the state of my cloud formation is in failed state or is in cancelled, if someone cancels it or if gets failed, then I want to trigger a lambda, which will send a message to my Slack channel. So if I have to do this kind of automation, then we can also configure the CloudWatch in this manner, like this. And yeah, for this event, we get an event pattern here. Here you can see the source is the code pipeline, and this is my detail, and the state is the failed and cancelled. So if this event occurs, then this target will be triggered. Yeah. So in this manner, we can do this. So sorry. So one thing we discussed in the code pipeline, that code pipeline in the backend use the CloudWatch event only. So how it works? So that we can also see here. So when we create a code pipeline in the console, it automatically creates a trigger in the backend. And here we can see that for this trigger, the source is code commit. So if something happens in this code commit, and then my CloudWatch event will come to know, and it will trigger my code pipeline as a target. So in this manner, the whole automation works. So we can see the importance of CloudWatch in the world of automation. Before going now to the next part, is there any questions so far? Uh, Okay. So I will go to the next service, uh, which is AWS X-Ray. So yeah, so AWS X-Ray, it gives a complete information about how my application is communicating with other application. For example, so with other services. For example, my application consists of Elastic Beanstalk environment. Then I'm having DynamoDB table. I also have SNS, and yeah, like this. And how much time it is taking to communicate to this kind of to these services, and for each API call, what is the average time, and these kind of things. So that we can also configure. We can also visualize using the X-ray. So in X-ray, we call this as a trace, and when we enable the trace, we can see this service graph. So this is like a service mapping, where we can see all these graphs. So yeah, we will go to the console part of it. For this, we will go to X-ray, and here. So this is the X-ray. So either we can create a sample application, or we can simply start instrumenting our own application, and this X-ray will be integrated. So for that, we can select that by programming language is based on which language. For example, I select Python. Then for this to work, we have to install a daemon, which is called X-ray daemon, on our yeah, on our instance to work. So like this, we can configure our application, and then we have a service map graph. So sorry. So this is the graph that we can say that looks in the service map, and then we have trace. Then we can give for which URL we are getting the error. So yeah, so using this we can analyze various things there. For example, if I have to, yeah, if I we can also change the timeline that from where I want to gather the information. Yeah, so using this we can analyze that how microservice. So in concept of microservice, it is a combination of multiple services, which communicates in a decoupling way. So it's also very important in the microservice world. So X-ray also plays a very critical role. And also we can also understand that how my web API calls are happening in the backend using the X-ray. Yeah. So next service is the AWS CloudTrail. So for all the services that we have implemented and that we know, uh, if I have to know that who is doing what in my account, or at who is doing what kind of changes in my account, so for that we can use the CloudTrail. So CloudTrail, it tracks the user activity as well as the API activity, which is happening in my account. So if we enable the recording of the CloudTrail, then we can see here that this user has created something at this given point of time. This has removed something. So like this, we can analyze, and we can know that who has done what in my account. And it's also very important from the audit point of view. So how it looks, how the logging of the CloudTrail looks. So here you can see the in the this we are having this type. We are having I am user as a type, and the name is the Bob. So this user is doing run instance this user is running an EC2 instance from this region and from this IP address. So we can also see that this kind of complete information we are getting using the CloudTrail, that who is doing what from where and on which service. So yeah. So and the other important use case of this CloudTrail is like so consider I'm having multiple accounts. For example, I'm having dev account, UAT, prod, stage, and or some other accounts. And for all the account, I want to the CloudTrail logs of those all account. I want to gather in a single account. So this CloudTrail also supports cross region and cross account access. So in this manner, we can collect the log of all the accounts in one central account. So that feature we will also see in the demo part. Yeah. So now we come here, go to cloud. Yeah. So here, this is the dashboard of the CloudTrail, and yeah. So it continuously log our AWS account activity. It captures, store, inact, and also we can review. And from the compliance point of view, this is, I mean, one of the important service in AWS. So yeah, the event. So here we can see we are getting a complete information. For example, we can see here that this user SAA has I've created this test event pattern on this service. Yeah, and also we can see that this user has removed something. That this has created a role, and this is the name of the role that this service has created, and what is the time when he deleted. So all these kind of things we can see that for which instance, and for also we can also see that this instance, if a user is doing something, then we can also know. And if some instance or if some role or API is doing something, then we can also see here that this instance is doing this API call or is doing this event. So like this, we can also see multiple things. So for this CloudTrail to work, we have to create a trail. So for example, we will go here and we will create a trail as demo trail. And it is asking me where to store that this trail, I mean these logs for the reference. So either we can create a new bucket or we can use the existing one. So for I'm creating a new bucket, and we can also encrypt this log that we are storing. So it's also very good that we are encrypting it, and we can use the, I mean, new, or we can use the existing one. Uh, And yeah, the most important feature of this is the log file validation. So one question arises here. So if I so currently I am monitoring and logging everything, but what happens if someone changes this log file in the S3 bucket? For that, this slot will support this log file validation, where it checks the integrity, it creates a digest file, and based on the hashing part, it checks whether that file has been altered or not, and we can send the logs to the CloudWatch. So using this, we can create a trail, and when we create a trail, it starts recording our service, and it will send the logs to the bucket we can see, and we can also see the glimpse of it in the event history part. So yeah, this is the CloudTrail part. So now, yeah, before now going to the next part, Sanchit, is there any question?
No, Ishan, I think we are good. Yep.
Okay, cool. Yeah, then we will go to the next part, which is the various tools. Using this, we can integrate. Using this, we can interact with our AWS. So we have multiple tools available, which is the AWS SDK, AWS CLI, AWS CloudShell. Then we have CDK. So we will go through each of them one by one. So the first one is the AWS SDK, which is AWS Software Development Kit. So this is the so consider I'm writing some application in Python language, and I want to make use of AWS services. For example, I want to stream something on Kinesis, or I want to make use of DynamoDB table from my application which I'm writing from the local machine. For that, we can install the SDK, and we can integrate the code for the this our Lambda or Dynamo table, and we can interact with the AWS services, and we can make that as a part of our application. So AWS SDK supports multiple languages. For example, it has support for JavaScript, Python, PHP, .NET, Ruby, Java, yeah, and all the languages available. So now what are the steps? For example, if I take example of Python, the name of the SDK is Boto3. So actually the name is, the SDK name is Boto, but the yeah. So and and we have to follow some steps. For example, first we have to install it, and for the Python we use this pip install Boto3. Then once we install it, we will simply import the Boto, and and then we will create a client for the service I want to. For example, I want to get some objects from S3 bucket. Then we will create a client for the S3, and then we will write a loop. And using this S3 dot buckets dot all this method, using this API call, we can we can get all the buckets which is created in my account. So in this way, we can interact with the AWS services. So I will go to the demo part of it, and we will explore how we can do the things. Sorry. Yeah. So here we can see. So I've written a code here. So this is a code where I'm importing the Boto3. So I'm using Lambda. In Lambda, Boto3 is already pre-installed, so we don't have to do the pip install thing. And now next we are creating a client of the Boto, where I'm creating a S3 client of it. And from this, I'm having this method s3.buckets.all. This allows us to get the bucket, and using this for loop, I will create the bucket name in a loop. So I will first deploy this, and when I create a test, it will run the API. And here we can see this is the name, the bucket that we have available in my account. Now, suppose you have to create some bucket. For that, we also have some API. So this is the method for this, where we have we're creating client, and then we are having this create bucket. And in this, we are giving the bucket name. So the bucket name is coming from here. So if it, and in this way, if I click and test, it will create a new bucket for me. And control is this one. Here we can see that this bucket has been created for us. So in this way, we can play with it, and we can interact with multiple services. So we have multiple Boto APIs available. So if we go to the documentation, which is boto3.amazonaws.com, so each service we have a long list of the API available. For example, if I want to copy object, if I have to create bucket, delete bucket, if I want to do some cross-region replication, if I want to simply get the object in bucket, or if I want to implement the bucket policy. So all these kind of things are available, and we get a complete, great documentation with all the explanation aware that which is the required parameters and what is the request syntax and response. So using this, we can interact with our AWS services, and we can use this in our code also, in our application part also. So yeah, so in the example, we can see that we can list all the objects in our S3 bucket like this. So we can also get sample codes available here. Yeah. So this was from the documentation side and the SDK. Now we have the CloudShell. So CloudShell is a tool which is like a we can say CloudShell it is like a terminal which is available on the cloud, which AWS has created. So consider, so earlier when we didn't have CloudShell, so if I have to run some shell script, or if I have to interact with the AWS services using the command, for that I have to simply create. So for that, what I have to do, I have to go to the EC2 instance. I create a mini version of it. With minimum configuration, and on that I will and once that is created, we can write the shell script. For example, if I have to interact with the AWS services. But now we don't have to do that. We just simply go to the Cloud Shell, and we will go to the Cloud Shell, and we will create, and we will start interacting with it. So for Cloud Shell, we can see either we can go to the AWS Cloud Shell using this user searching from here, service, or we have a short this icon here. Using this, we can also go to the Cloud Shell. So it takes some time to configure. Yeah. So till the time we will understand the the theory part of it. So CloudShell is like a pre-authenticated with the console credentials. For example, what it means, that I have logged in as the SAA user. So this will take the credential and the access that I have, and all the access that I have. So I will be able to perform this through the CloudShell. Next, we can use the CloudShell from the browser, and we don't have to pay any additional cost for it. Also, all the common packages like Boto 3 and all, it's also pre-installed, so we don't have to worry about it in the installation part. So how it works? So Cloud Shell creates a session in the backend, and in this we can store up to 1 GB of files. So yeah, so that is also a good feature of it. Uh, and next part is the AWS Cloud Shell. So we will cover the Cloud Shell and the CLI demo together. So next is the AWS CLI. So CLI is like a command line interface. So as we saw in the SDK part, if I have to integrate something in my application that I'm writing using programming language, therefore that we have this AWS SDK. But what if I have to write some shell scripting, and I using that shell scripting I want to interact with the AWS. For example, I want to interact with S3 bucket using the command line. For that, AWS has also one service which is AWS CLI. Uh, and yeah, so in CLI we have CLI available for multiple services also. For example, we have separate CLI for Elastic Beanstalk. We have a separate for ECS as well. And yeah, so for CLI to work also, first we have to install it like this using this method using curl. Then we will simply check the version of it, and using this command we can interact with the AWS services. So now we will see in the demo part of it. So here we can see this is the console of the AWS Cloud Shell, and here we can write a simple all the Linux commands. For example, I do ls, or we can do touch s.txt and things and ls. So yeah, all the Linux commands are supported, and we can also interact with the AWS using the AWS CLI. For example, if I have to get a list of all the buckets available in my account, for this I will use AWS S3 In this, uh, it lists all the buckets available in my account, and if I have to uh, create a new bucket, for example, then I can use AWS S3 MB. MB is from make bucket. If I have to copy something, then you can use CP like this. First, I have to create a new bucket. We will write MB, and then we will use SW demo. Oops. So, right. Yeah, for this S3 bucket, we have to follow some pattern like this S3 colon slash like this. If I create, now this we can see. I think this is visible. We can see that this bucket has been created. And now, if I again go and list this, if I search this, you can see this bucket is available here. So in this manner, I can either play with S3 or all the services which are available with AWS. This Cloud Shell also supports one other feature is like this. We can also upload file or download file. So as we saw, that it supports 1 GB of storage. So we can also play and do some building and testing part also for here. So this is also a great service to play with. Yeah. So next service is AWS CDK. So we saw in the CloudFormation part that if I have to create something, then we have to write a YAML or JSON version of it, right? But what if I don't want to write a YAML or JSON? I want to write a code in my Python language. I'm good with it. So for that, AWS has also come up with a service which is AWS CDK, which is Cloud Development Kit, in which we write the code in our favorite language, and that code, when we compile it, it will create the YAML or it will create a YAML JSON version of it, and that we can deploy in the CloudFormation. So we don't have to worry about writing the YAML version or JSON version for creating the infrastructures. So for that, so we can see that it supports all the languages like, for example, Python, Java, JavaScript, TypeScript, C#. These are languages available. And for this to work, we have to follow some steps. First, we have to initialize the app. For example, I'm to use a Python language. Then in the language config, I have to give the Python. Then we have to activate the Python version, and then we have to install some packages that we will see in the demo part. Then using this code, I will write some coding part which will create a S3 bucket. So, and we also have multiple commands available that we will also see here. So now we will come here. So I think this editor is visible, and we will come here and we will create a folder which is CDK. Now, if I go to the CDK part, here we have some steps mentioned. Yeah. So first we will copy this. Come here, we will first go to this folder which is CDK. And here we will first initialize the app. So you can see we have CDK initialize. With the name of the app is we are giving app, and the language is Python. Here we can see that it is creating a virtual environment for me. And now the virtual environment is created. Now we will enable the virtual environment. Now we can see the env is there. Now we will install. So now we can see when we ran these two commands, it has added some folder inside my file. So here we can see this virtual file also. We have this folder and we have this requirement.txt. And here it will install AWS CDK library and the constructs. These two dependencies are required. So that we will be installing here. And here we can see requirements.okay. Sorry, my bad. Here it is installing the dependencies. Once that is done, so here we can see we are having this folder named cdk_demo. In this we will be writing our code. So here this is the file where we were writing. For this we are sample code that we already have, which is here S3 bucket. So we'll be creating one bucket here. I will replace this one with the new code here. So here we can see we are importing the AWS CDK as CDK that we do in Python, and then we are importing the S3 S3 module, and in the class we are creating S2 and here in the bucket we can see we are using S3.bucket method of it, and we have enabled the version of this bucket, and the bucket name we are giving this. For example, I can give this name. And now when I come and so we will write the CDK synth command. So CDK synth command, what it will do, it will create so currently we can see here we don't have any out folder. Okay, so it will dump the YAML or JSON output of it in this file, in this folder. For that we will write CDK synth. It will synthesize my code and it will create, but we will get one error here first. So first we will resolve that error. So you can see we cannot import. This one. We will replace the name of the class with this new one. Now we will run. So once we do CDK synth, it will. So you can see we are having this out folder, but currently this is blank. But now, so now we can see some file is got created here. Now if I come here and see this JSON, we can see this is the CloudFormation template in the .json version. Here we can see the type is of bucket. In the property we can see versioning is enabled, and also the name is this is the one that we gave, and we have all the conditions and all the things. This is the default one. So we can see using this command we got this CloudFormation template, and if I want to deploy this, then I have to simply use this CDK deploy. And if I want to destroy the created infrastructure, then we will use the CDK destroy command. If I want to check the applications or stacks, then we will use the CDK ls command. And if I want to check the difference between the files, then we can use the CDK diff. So these are all the commands available. Using this, we can play with it, and we can we can get that output, CloudFormation output. So now we will go to the next part of the of our session, which is the AWS Secrets Manager. So Secrets Manager is a AWS service which is used to store our credentials in some separate location in a secure manner. So ideally, when we create some service, and if I'm having RDS or Redshift cluster or any DB, so we don't hard code the username, credentials, this kind of things in the code. So what we do, we store in some separate location, and from there we access it in our code. So for that we have AWS Secrets Manager. So and from the pricing side, we can see that we don't have to. So we only for the number of the secrets we stored or the API calls. So you will see that, and so we will see this in our demo part, which is okay. So here we can see this is the AWS Secrets Manager console, where we can. So one of the important feature of the Secrets Manager also we can that is that, for example, I'm having one. I'm storing some credentials of in my Secrets Manager, and there's a requirement that after every 30 days, I want the credentials to be changed in an automated manner. So for the security point of view, this is also important. So this feature is also supported by Secrets Manager. So it comes under easily rotate. So we will see if I go to click and store a new secret, we can see that we can. So this is also integrated with RDS and Redshift cluster directly. So if I have some RDS cluster already created in my account, so I will simply come here, and it will come in this block here. I will check this box, and it will get attached. So this credential will be attached with this cluster. We don't have to go to that service and configure there. So this is also important feature of the Secrets Manager, that RDS and Redshift is directly integrated. But what if I want to store some API key or some authentication? For example, I want to store like this user name test and password is yes. Password is 123. For example, so for that we can also use this in the plain text. We see like a JSON structure, and but in the key value we see like this, and it is also it is encrypted by KMS. So it is also more secure. Next, we have to give a name. For example, and we will. So here we see, here comes the important part, which is the secret rotation. In which, if you enable the rotation, then it will automatically we can select timeline. For example, 30 days. Then after every 30 days, it will do a rotation of my credential in an automated manner. But for this to work, we have to configure one Lambda for it, and then Lambda will get triggered every 30 minutes. And again, CloudWatch event will come to the picture in the backend, which will trigger this Lambda every 30 days, and then again it will happen. So now if I go next, and here, so here we can see if I click on commit store, and if I do a refresh here, if I see here, we can see that secret is not displayed here. But if I come here and click on retrieve, then we can see. But if I want to access this secret that I've created here in my code, for example, I'm writing a code in Python, and I want to access it from my code. For that, we also have the API call, and again, this is the SDK, which is the AWS SDK. For this, we are having Boto 3, and using this, we are creating a client session of Secrets Manager, and using this get secret value, this method, we will get the secrets that we have stored here, and we can integrate in our code without hard coding our credentials. So you can see that this service is also very important from the security point of view. Now the next service is the AWS System Manager. So System Manager, so this service is mostly a combination of multiple services. So, but in simply, if I have to explain, then it is used for the complete management, end-to-end management of the whole application, and it was also supported for the hybrid cloud and thing. So that we will see in the console part of it. So yeah, so here we can see this is the Secrets Manager console, where it combines so you can see it has multiple services available. For example, if I have to summarize, then yeah, it is used for operation management, application management, change management, node management, and all the services. So we will go through the important services that are available for us for now. For example, the parameter stores. So, so we saw one thing, that in Secrets Manager we can store our credentials. So we can also use this parameter store for our storage, and yeah, we will understand the difference between those and when we can use what service, like that. So if I use this secure string and using this KMS, I can also store some credentials here. For example, if I wish to do something, then here you can see this is coming in the protected way. But mostly we can use this for the parameter stores. For example, uh, I'm having an application which is writing something, and I want some other application to behave based on the output of that application. So first application will write or take the parameter from here and update something, and the next service will again take input from here, and based on the configuration it will work. And we can also use this parameters SSM parameter store for storing the config file. For example, we can write this config like this, uh, is available, like for example we can write this config like this. For example, if I have some application which is running, and if one application sets this as a true, then only my other application will first read the value from here. If it is true, then only it will start executing. So like that, we can also decouple multiple things, and we can also use this for for storing the storing the parameter or the config file or the configuration. Then the other next service we have is the session manager here. So so now we have EC2 instance, and if I have to connect to the to this instance using the SSH, so the one way of doing the thing is to connect using the SSH, and other is the way of doing the thing is like a session manager. So for that we will simply click and start a session, and we will. So but for that, so here we can also see that session manager is also directly available here. Yeah. So as you can see, for that we have to install the session manager, this agent, and then we can simply start here and we can click and connect, and it will create a secure connection between my instance and and me. So this is also important feature, that instead of having using this EC2 instance connect, we can also use this session manager without having the SSH key and all this configuration required. And this session manager also records. For example, if I am creating some file inside my folder, inside my instance, or if I'm installing some package, then this session management will also come to know that who is doing what in my EC2 instance. So this is also very critical service. So yeah, that's all from this system manager. We, yeah. So now from this we have, next part is the difference between the secrets manager and the parameter store. So first we will see that from the pricing point of view, this parameter store is completely free. We don't have to pay for it, but for this we have to pay for the number of secrets stored and also the API calls. And next is the built-in password generator. So we saw that in using Secrets Manager, if I store something and if I want to update or change the password every 30 days, then this option is supported here, but it is not supported in parameter stores. For the cross account access, for example, I'm having multiple accounts, but I want a separate account for storing the credentials only. That we can also achieve using the Secrets Manager, but that option is not available in the parameter stores. And then from the encryption we can encrypt both, but for the integration with the RDS and Redshift, the integration is with the Secrets Manager that we saw in the Secrets Manager console, but it is not available for the parameter stores. So yeah, from this I've come to the end of the session. Now yeah, I would like to appreciate the organizer and the volunteers that who are doing a great job, and thank you so much.
Thanks, Ishan, for that wonderful session, backed by a couple of good demos. I think this was really a good learning for every one of us in last 2 hours, right? So I would request all the folks who are live, please post your questions on the chat. We'll have a couple of minutes uh, more. So if you have any questions about the sessions, about the next step, please post around it. Throughout the sessions, we saw a couple of interactions where people are very interested around how to join the Discord study group and all, right? So we will, for sure, for the folks who have registered with us on the Google form, tomorrow, after our both the sessions for this week, we will send out the materials for this week as well as a Discord link in that same email, which you will, via which you will able to get into our study group. And rest assured, in case if you are not able to do that, please reach out to any of our organizers. We will be happy to talk to you offline and resolve any sorts of issues which you are having around that, right? And again, for the folks who haven't joined with us, please do join today. The Google form link is given in the description of the video. And again, it is there in the chat section. So please do register, and we'll share all the materials and all the tips what you require to focus on the certification. That's what you can get from that study group. So that's what we had for today's session around focusing on the DevOps services. I'll like to recap. Tomorrow we'll have uh, the session which will be focusing on the networking part, networking services like VPC, Direct Connect, Route 53, CloudFront, which will be conducted by Faisal. He's pretty expert in networking side of it. So please don't miss. The session will be at 2:30. The link of YouTube channel is already there under AWS User Group India. So don't miss and please do join. And if you have any other further questions, any help you need, please feel to reach out to any of our organizers. We will be more than happy to help you out with that. So that's what we have from today's session. We'll take for a few more minutes to see if you guys have any other questions. We'll be happy to answer. And again, I'll like to recall all the active participants throughout this bootcamp. At the last session of the bootcamp, we will rewards AWS certification voucher or credits for any active participation throughout the bootcamp. So please actively join all of our sessions, participate on the chat group, and yeah, look forward for the winning prize. So we'll take few minutes and we'll see if there is no question, then we'll wrap up for today's session.
Sure.
So yeah, I can see a question which is around some help around the serverless app with CDK. So for sure, if you want to post your question, you can do it. If you seems like it's a bit about confidential or specific to topic in CDK, you can for sure reach out to Ishan over LinkedIn or to me. We will help you to get to the right SME or expertise which will help you to solve that. So however you are comfortable, if you want to address it now, you can do that. Or if you want to take it offline, we will be happy to take that offline also. So yeah, I think we are good for today's session. Thank you so much for everyone for being actively patient throughout the session. Thank you, Ishan, for spending your precious time from this weekend and walking us through with your expertise on DevOps and different things what we can do. And looking forward for more such contribution in upcoming weeks. Thank you so much. Stay safe. We'll be looking forward for tomorrow's session at 2:30. See ya. Take care.